So here we're going to look at a few examples of filling in Venn diagrams with numbers. So we're going to talk about union, intersection, complement, and we'll do a few examples, and there's a little bit of probability in here as well. So the first thing I'm going to talk about here a little bit is the intersection of events. So suppose we have a class of 100 students, and suppose of those 100 students, we've got 40 that study biology, and of these, 12 of the students study both art and biology. And suppose that 36 students study art. So we're going to create a Venn diagram to reflect this information. Okay, so if you've encountered something like this, maybe in a probability course or a finite math course or a discrete math course, what we're going to do, again, is just create a little Venn diagram. And a Venn diagram, you just make a box like I have. Usually make two equal-sized circles. And what we're going to do is we're going to label. So each circle is going to represent a set of students. So I've got one set of students here. I've got another set of students here. And then we have this intersection or the overlap of the two students. So I'm going to label this set as A, and that's going to be the number of students. That's going to represent the set of students, that study art. So A for art. And then we've got our set B. That's going to be the set of students that study biology. So a lot of times you'll put a little U because this box represents your universe. It's sort of everything that's under consideration. So what we want to do is we want to start filling in numbers into each of these places here. So we know that 12 students study both art and biology. So that's going to be the intersection. So we know that the number of students that study art and biology, so again, stands for the number. There's our set of students that study art, our set of students that study biology. And the intersection, this little upside down U, that stands for you can think about that as being the word and. So we're looking at the number of students that study art and biology. Well, we know that's equal to 12. Well, what we need to do is we're going to put a 12 in this middle part because we need it to be in the art circle, right? So it's in the art circle, but it also has to be inside of the biology circle. So the 12 represents the students that study both art and biology. So if we look at, for example, the part of the circle that I have shaded here, so this is going to represent the students that do art only. Because if they included this part again, well, that means they also study biology because they're in the biology circle. So if we look again at this little set, this shaded part on the left, those are going to be the students that do art only. Well, let's see if we can figure out the number of students that do that. So we know that 36 students study art. And this doesn't mean that 36 students study only art. This means that 36 students in total study art. Well, what we can do is we can take our 36 students, subtract away the 12 students that do both art and biology, and that's going to leave us with 24. So I would fill in a 24 here. So that tells me that there's 24 students that do art only. They're not studying biology as well. So we can do the same thing when we shade here. If we look at this part of the circle, those are going to be the students that do biology only. They don't study art. Well, again, I know that 40 students study biology. Maybe they study other stuff like art. So if I want to figure out the number of students that do biology only, I'll take 40, and again, I'll subtract 12, and 40 minus 12 is going to leave us with simply 28. So those are going to be the number of students that do biology only. So I'll put a 28 here. Now, we're going to put a number out here as well. And since it's outside of the art circle or the biology circle, those are going to be the number of students that study neither art nor biology. So if we want to look at that, so the number of students that do neither, well, we know that we were talking about 100 students total. So if we take our 100 students total, we can subtract away 24, the students that do art only. We can subtract away 12, the students that do both art and biology. And then we can also subtract away 28, the students that do biology only. And if we do 100 minus 24 minus 12 minus 28, that's simply going to leave us with 36. So we've got 36 students that do not study art or biology. So now we've got our Venn diagram labeled. So let's look at another example here. So here I've got a group of 50 people, and of those we have 29 like eating fish, so I'm going to use an F for my set there. So let me even go ahead and make my Venn diagram here. Let me put my box in here. My rough looking little box. So I've got people that like eating fish, so we'll label that with an F. We have 38 that like eating chips. Okay, so I'll put a C up here for chips. And 9 people like neither fish nor chips. And we want to know how many people like both. Well, I know that there's already 9 people that like neither fish nor chips, so I can put a 9 out here because they wouldn't belong in either of those 2 circles. So again, we've got 50 people total. Let's see, so we know, okay, we're trying to figure out how many people like both. That's what we don't know, so I'm going to label that as X. That's what we're trying to figure out. Now, I know that 29 people like eating fish. Maybe they like eating chips as well. So I know to figure out the number of people that like, say, fish only. Well, that's going to be 29 people in total, but I'm going to subtract away X because that's the number of people that like both. So the idea is when I add this number plus this number, it has to equal 29. The same thing, I know that 38 people like eating chips, so I could make this value 38 minus X, because that's the people that are going to like chips only. And again, if I take X and add 38 minus X, that's going to add up to 38 total. Well, just like before, if I take this value, 29 minus X, plus this value of X, plus 38 minus X, plus 9, that has to add up to all of my people. That has to add up to 50. So let's see if I can fit this in here. So 29 minus X, so that's the people that like fish only, plus 38 minus X, that's the number of people that like chips only, plus X, that's the number of people that like both fish and chips, plus 9, that has to equal the total number of people that we were looking at, which is 50. So you can check my arithmetic here. 29 plus 38, that's going to give me 76. So negative X plus negative X would be negative 2X. Plus an X is just going to leave us with minus X. And let's see, so I said 29 plus 38, plus 9, excuse me, that's going to give me 76. I think I left out my plus 9 there. So 76 minus X, that has to equal 50. Well, we can simply add X to both sides. Well, we would have 76 minus 50 on the left side, and that's going to leave us with 26. So 26 is going to be our value of X. That's going to be the number of people that like both. So now we've got 26 here. So we could even go back and relabel our diagram a little bit. So we know that 26 people like both fish and chips. So if I do 29 minus 6, that means that there's 3 of those people that like fish only. Likewise, I knew that if I take 38 minus X, well, that's going to be 38 minus 26. That's going to give me 12. So there's 12 people that like chips only. Okay, so a couple of things here. So we're going to use the diagram to find the probability that a person chosen at random from the group, what's the probability that they like chips? Well, the probability that they like chips, we count the total, we look at the number of people that liked chips, and we said that the number of people that liked chips in total, that was equal to 38. So 38 people liked chips, and that's out of a total of 50 people. So the probability that a person chosen at random likes chips is going to be 38 out of 50, and that reduces to 19 over 25. Let's see, the probability that a person likes fish, but not chips, well, okay, it's the same idea here. They like fish, but not chips. So the probability that a person likes fish, but not chips. Let's see, so the probability that a person likes fish, but not chips. So we could write that as saying the probability they like fish, and so we're going to talk about the complement. So C represents the set of people that like fish. We put like a little apostrophe up here, and that's the complement. So if the set C represents the people who like fish, the complement of that is the people who do not like chips. So that's what that notation means. So this says the probability of people that like fish and don't like chips. So that's how we can represent this sentence using notation. Well, let's see. The number of people that like fish but not chips, we said that was only equal to 3. And again, at a total of 50 people. So that's the probability the person at random likes fish but not chips. And the same thing. So in our last question here, we were asking what does the set F complement union C represent? And we want to know how many people belong to the set. So this says they do not like fish. The union, you can think about that as being or C do like chips. So we're going to try to figure out what that set represents. If we want to talk about how many people belong to this set, we can write it in this notation. So we're looking at the set of people who do not like fish or do like chips. So let's see. So if they don't like fish, that means, well, they do like chips. And again, as long as they like chips, that's okay as well. So we'll also include this overlap. And then we'd also include the people that don't like either. So in this case, we would have our value of x, which we said is 26, plus 12, plus 9, and that's going to give us a value of 47. So 47 people either do not like fish or they like chips. So be careful. I know this part says they don't like fish, so you might think we shouldn't be including this value of x. But it says, or as long as they like chips, that's okay. We're going to include them. So that's why we're including that value of 26. So let's see. Let's look at a Venn diagram with 3 sets. And I think when you first see this one, it's going to look like information overload. So we've got a college with 200 students, and they offer rowing, kayaking, surfing as activities. So of the students, 8 do all 3. So 8 do all 3, 30 do rowing and kayaking, 20 do rowing and surfing, 10 do surfing and kayaking, but not rowing, so that's going to be useful. 40 do only rowing, okay. 70 do kayaking, and 48 do surfing. So here we're going to sketch a Venn diagram again to get all of this information. So let's see, I'm going to be going back and forth up here, sort of up and down. So let's make our Venn diagram. I'll try to make it a little more quickly. Okay, so we've got 3 circles in this case because we're talking about 3 different groups of people. Okay, so we had people that did rowing. I'm going to label that as R. We had people that did kayaking. I'm going to label that as K. And then we had people that did surfing. So again, we know we have 200 people total. So let's see what of our information we can use first. So I think the first thing that I'm going to use is that we know that 8 do all 3 of these activities. So 8 people do all 3 of the activities. So that means my value has to be in the rowing circle, it has to be in the kayaking circle, and it has to be in the surfing circle. So if you think about shading these, it's got to be in the rowing circle, it's got to be in the kayaking circle, and it also has to be in the surfing circle. So it has to be in all three, and I think you can see that this part in the middle, that's the most shaded part. That's the overlap. That's where if you put a value there, that's when you're in all three of those circles. So my value of 8, the people that do all three, I'm going to put that right there. Okay, so we've got rid of that little piece of information. Let's see, and there's sort of different ways we can go about it here. Let's see, so what am I looking for here? Okay, so let's see what's next. Okay, so it says 30 do rowing and kayaking, so let's use that one next. So 30 do rowing and kayaking. So that means I need to be in both the circle R and K. Well, this value is in the circle R and K. And notice this place here would also be in R and K. So if I add those together, so if I take this value plus this value, that's going to be the number of students that do rowing and kayaking. Well, I've already got 8 of those students labeled, so I would need a 22 here. That would be, again, giving my total of 30 students. So same thing, we can say, well, 20 do rowing and surfing. So 20 do rowing and surfing. So if this value 8, again, is in the circle of R and S, so those students count towards people who do rowing and surfing. And notice this part of our Venn diagram would also be in the circle R and S. So likewise, if I add those two values, it's got to add up to 20. So it looks like, well, 12 plus 8, that's going to add up to 20. Let's see, it says 10 do surfing and kayaking, but not rowing. So 10 do surfing and kayaking, but not rowing. So that means that I have to be in the S circle, the K circle, but not the R circle. Well, if I want to be in the S circle, the K circle, but not the R circle, I think that little portion right there would do it for us. So this little region that I have shaded here, those are the number of students that do rowing and surfing, but not kayaking. So it says that 10 of those students do that. So we know that we'll label that as 10. So it's got to be in the surfing circle, the kayaking circle, but not the rowing circle. So I've got 10 students that do that. Let's see, what else do we have? It says 40 do only rowing, right? 40 do only rowing. So that means I've got to be in the R circle, but not in the K circle or the S circle. So this region would put me in the R circle, but not the K circle or the S circle. So the value that we drop in there, those are going to be the students that do only rowing. Okay, well, we're told that that's equal to 40. Okay, so we've got that. It says that 70 do kayaking. Okay, so 70 do kayaking. So if I add up all the numbers in the K circle, it has to add up to 70. So I'll put an X here. So I know a few of my values, right? We've got 22 plus 8 plus 10. Those are all values that are in the K circle. And if I add X to that, I know that that had to equal 70. So let's see, 22 plus 8, that's 30, plus 10, that's 40. So 40 plus X has to equal 70, which would tell me that X equals 30. So let me clean this up a little bit. So I now know that X is going to equal 30. And let's see, same thing. We know that 48 do surfing. So if I add up all the numbers in the S circle, that has to add up to 48. So if I take 12 plus 8 plus 10 plus X, 12 plus 8 plus 10 plus X, that's got to equal 48. Well, 12 plus 8 again is going to be 20, plus 10 is 30, so 30 plus X equals 48. And if we subtract 30 from both sides, we'll get that X equals 18. Okay, so I think we've almost got everything labeled here. We still have to look at the number of people that do none of these things. Let's see, so we had, what, 200 people originally? So we started with 200 people. So we're just trying to figure out the value outside, the number of students that do none of these activities. So I could take the total number of students, and I don't even know if I calculated this one. We can do this one real quick. So let's see, the total number of students is 200. I'll subtract away basically all of these values. And that's going to give us the number of people that don't do any of these activities. So I'll subtract 40 minus 22 minus 30 minus 8 minus 12 minus 10 minus 18. And what does that give us? So let's see here. I'm just going to add them up. So let's see. 22 plus 8, that's 30. 12 plus 18, that's another 30. So this and this is going to give us 60 students. We've got another 40. So that's going to be 100 students plus another 30. That's going to be 130 plus another 10. That's 140. So it looks like we're going to have 200. It looks like we're going to have 200 minus 140 once we add up all of those numbers, which means that there's going to be 60 students that simply don't do any of those activities. Okay, so we'll put that number out there. So now we've got our Venn diagram labeled. Whew, okay, a lot of information. So how many students do none of the activities? Well, we just figured that out. There's 60 students that do none of those activities. So that would be our solution for part B. So if a student is chosen at random, find the probability they do rowing or kayaking. So the probability they do rowing or kayaking, well, we would have to just add up all of the numbers in the rowing or kayaking circle. So let's see, this is in the rowing circle, rowing circle, rowing circle, rowing circle. This is in the kayaking circle and the kayaking circle. So if we add all of those together, let's see, what do we get? So 40 plus 22 plus 8 plus 12 plus 30 plus 10. Let's see, so this is 30. So that's going to give us 40 plus 30, which is 70, plus another 30. That's going to give us 100, plus 10. That's going to give us 110, plus 12. That's 122. So it looks like the probability that somebody does rowing or kayaking, that's going to be 122 divided by the total number of people, again, which was 200. And I'll let you simplify that one down. I'm not going to, I'll let you do that one. That one shouldn't be too bad. So they do rowing or kayaking. So let's see. Part 2 says the probability that they do not do rowing. So the probability that they do not do rowing. So right now, this would say the probability they do rowing, but I'm going to put a complement here. So the probability they do not do rowing. So I left my thing shaded. Let me kind of shade with a different color here. So if they don't do rowing, we just have to look at everybody outside of the rowing circle. So let me use a darker color here. So the 30 would be outside of the rowing circle. The 10 would be outside of the rowing circle. The 18 would be outside of the rowing circle. And our 60 would also be outside of the rowing circle. So we can add all of those together. So 30 plus 10 plus 18 plus 60. And we would, again, divide that by the total number of people, which is 200. And again, let's see. So that's 30 plus 10, which is 40, plus 60 is going to be 100, plus 18. That's 118 divided by 2. And again, I'll let you simplify that down, right? Top and bottom are both even, so you can certainly divide numerator and denominator by 2 to reduce that a little bit. So, okay, I hope this video helps and makes some sense. And yeah, like I said, especially when you see these with 3 sets, they can be a little overwhelming. But I think as long as you're sort of shading your region, you know, and you just really make sure what that portion says, you know, what that region represents, then I think you'll be in good shape. Yeah, once again, hope it helps, hope it's not too confusing, and I hope it clarifies some things for you.